Good morning, friends. So today we are going to see the topic on metric spaces. So metric space is very important when it comes to any competitive examinations, or even in your school, from your college point of view also it is very important. So let's begin with metric spaces. Metric space. So a non-empty set X with a metric defined on it is called a metric space. You can say a metric space as X comma D is a metric space. Okay. So a metric is nothing but a function from X cross X to positive reals. Okay, because metric is something we call as distance, so that should be always positives. So your range should be always 0 comma infinity. Okay. Now metric should satisfy 4 properties. What is the first property? D of X comma Y is greater than or equal to 0 for every X Y belongs to X, and D of X comma Y, that is distance, is equal to 0 if and only if X equal to Y. Third property is what? Symmetry property, correct? D of X comma Y equal to D of Y comma X for every X comma Y belongs to X. Fourth one, D of X comma Y is always less than or equal to D of X comma Z plus D of Z comma Y for every X, Y, Z belongs to X, correct? So this are the 4 properties that your metric space should satisfy. Now let me give some problems. Let's go from the basic. Okay, so the first one is usual metric. So usual metric is nothing but modulus of X comma Y for every X comma Y belongs to Z. Okay, this is usual metric. My Z is odd, so usual metric in odd. So you can talk about metric only in real, correct? So yeah, let's check whether it is a metric. What is the first property? D of X comma Y should always be greater than or equal to 0, correct? So if you take D of X comma Y, here you are defining that as modulus of X comma Y, which is always positive. And the second property comes as a result of the first property, correct? If modulus value is equal to 0, what does that imply? If X minus Y equal to 0, correct? You can also put if and only if. So this implies if and only if X is equal to Y. So this is the second property. What is the third property? So this is positive definite. What is the third property? Symmetry property, correct? That is D of X comma Y can be written as modulus of X minus Y. So you can just take minus common, Y minus X, which is equal to D of Y comma X, because modulus of negative value will be positive value, and hence you can say D of X comma Y equal to D of Y comma X. What is the fourth property? Triangular inequality. D of x comma y should be less than or equal to d of x comma z plus d of z comma y. Now, what is this? Is d of x comma y, correct? So this is equal to, if you add and subtract value, so we know that a plus b, which is always less than or equal to mod a plus mod b. Substitute that into here, which is less than or equal to x minus z plus z minus y. So from this you can say this is nothing but less than or equal to d of x comma z plus d of z comma y. Suppose this is a metric on OR. So the second metric is discrete metric space. Discrete metric space. So what is a discrete metric space? The distance between any 2 points, if you take any two value, 1 if x is not equal to y, 0 if x is equal to y. So this is a discrete metric space. So does this follow or satisfy the axioms? Let's check. So distance between x comma y is 1 if x is not equal to y. This implies this is strictly greater than 0. Second one, distance between x comma y equal to 0 if and only if x is equal to y. Okay, this 2 comes from the definition. What is the third property? Is symmetry. D of x comma y is equal to y, 1 for every x comma y belongs to z. So that is equal to d of y comma z. What is the fourth property? Triangular inequality. So d of x comma y, which is 1, which is always less than or equal to 1 plus 1. So this also holds. So this is a discrete metric on OR. So the third one is something we call as okay, I'll give you some definitions now for the metric spaces. You can understand from the property. So So D1 and D2 be two metric spaces. Rho of x comma y is equal to maximum of D1, D2. So what my question is rho a metric space? Very simple. First you check the properties. What is the first one? D of x comma y should always be greater than or equal to 0 for every x y belongs to z. So here rho of x comma y will be the maximum of these two values, which must be 0 for every x y belongs to x. Now d of x comma y should be equal to 0 if what happens if x is equal to y? Since D1 and D2 are metric spaces, okay, or metrics, okay, so D1 and D2 are metrics, it satisfies the four axioms. And hence this is true, correct? So if you choose row of x comma y to be some maximum, suppose if without loss of generality, if D1 is a maximum among the two metrics, this satisfies the axiom, and if x is equal to y, this gives you 0. Correct? If and only if x equal to y. So the second property also holds. What is the third property? The third property is distance between x comma y should be equal to distance between y comma x. So this is also true. Without loss of generality, if you choose D1 is the maximum among two matrices, row of x comma y equal to D1 of x comma y. Since D1 is a metric, you can say D1 of y comma x. So this you have chosen from maximum of D1 of y comma x, comma D2 of y comma x. Correct. Hence you can say row of x comma y is equal to row of y comma x. Fourth property is triangular inequality. D of x comma y should always be less than or equal to d of x comma z plus d of z comma y for every x comma y comma z belongs to x. Correct. So what is d of x comma y? Maximum of d1 of x comma y comma d2 of x comma y. So this is x comma z is maximum of d1 of x comma z plus d2 of x comma z. What is this? Maximum of d1 of x comma z comma y comma d2 of z comma y. So if d1 is maximum among the two matrices, d1 of x comma y, which is always less than or equal to what? d1 of y comma z plus d2 of is a maximum. So this, since this is a metric, it satisfies triangular inequality. X comma z plus d of z comma y. So what can we conclude from this? So this is chosen from maximum of d1 of x comma y and d2 of x comma y. Maximum of d1 of x comma z, d2 of x comma z plus maximum of d1 of z comma y, d2 of z comma y. So from this you can say, what can we say? Row of x comma y is less than or equal to row of x comma z plus row of z comma y. So this also satisfies, and hence row is a metric on x. My question to you is, row of x comma y is equal to minimum of d1 of x comma y and d2 of x comma y, where d1, d2 are metrics. So my question is row a metric on x? Okay, x be any non-empty set, say R. So does this form a metric space? This is my question. Let's try to solve. So minimum of something. So first property, it obviously holds, because if you take any minimum, that is a metric which will be greater than 0. Second property is what? Row of x comma y is equal to 0 if and only if x equal to y. Okay, minimum of any two metrics which will be 0 if and only if x is equal to y, since d1 and d2 are metrics. So this is the reason. What is the third property? Third property says symmetry. Okay, so is equal to row of y comma x. You can simply substitute this d1 of x comma y and d2 of x comma y is equal to minimum of d1 of x comma y and d2 of x comma y. Correct. So from this you can say what? Minimum of, since d1 and d2 are matrix, y comma x and d2 of y comma x, it is equal to minimum of d1 of x comma y. Which both are same, correct? Because you can rewrite this as y comma x. So this property also holds. Fourth property we have to check. Triangular inequality. Rho of x comma y is which is always less than or equal to rho of x comma z plus rho of z comma y. Correct. So if you check this property, rho of x comma y is minimum of something. Suppose if I take minimum to be rho 1 of x comma y. Sorry, d1 of x comma y. So if my d1 and d2 of, let me choose this to be 4, this to be 5, and d1 of x comma z to be some 1, d2 of x comma z to be some 2, d1 of x comma y to be, sorry, z comma y to be 2, d2 of z comma y to be 1. What will happen? This is minimum of these two values. So 4 should be less than or equal to, let's take this is 3 and this is 4. So this is x comma z, correct? So this minimum is 2, 3 and 4. 4. Does this work? Rho of x comma y. Minimum is 3. Oh, sorry. I was correct, I think. So this is equal to 1. This is equal to 1. Suppose you take like that 1. So 4. Is 4 less than or equal to 3? No. So what can we conclude now? Rho of x comma y is equal to minimum of some d1 d2 matrix. This is not a metric space. Rho of x comma y is equal to maximum of d1 d2. This forms symmetry. So thank you everyone.